Hi everyone, it's Mrs. Cardos, and I'm here today to do a little mini lesson with you for box and whisker plots. We are in the middle of our statistics unit, and so this is just a great time to talk about a box and whisker plot, what it is, and how to read one. So if you need a paper and pencil, stop the video, go grab it real quick, and then come back to the video. Remember, you can stop the video at any time today to try a problem, see what you can come up with on your own, and then turn the video back on to see if you get it correct. So our learning target for today says students will be able to answer questions about a set of data using a box and whisker plot, as demonstrated by the successful completion of practice problems. So the first thing we need to know is, what is a box and whisker plot? What's it for? Why would I want one? So a box and whisker plot is a way of organizing a set of data so that it is easy to understand. So it helps us to organize our data and it makes it easy to understand. So for instance, if I have a large set of numbers, like let's say I'm doing a survey or a science experiment, and I've collected a set of data, looking at a long list of numbers is not always very helpful. So a box and whisker plot can help me to organize it in a way that is more meaningful. So think about like times you might want to use a bar graph or maybe a pie chart. This is just gives us another option of a way of graphically organizing our data. And it especially helps us to see the variability or how spread out the data is, or the consistency of the data. The consistency would be if it's tightly grouped. So those two things are kind of opposite. Variability being spread out, consistency being closer together, tight knit. So in order to understand one, let's try making one. So I have this set of data here. And whenever I want to make a box and whisker plot, the first thing I need to do is I need to put my data in order from least to greatest. So I'm going to go ahead and rewrite my numbers in order from least to greatest. If you want to pause the video and do that on your own and then come back. So I see 3, I see 4, I see 5, I see 1 6, I see 2 7s, I see 1 8, 2 9s, and a 10. 1 2 3 4 5 6 7 8 9 10. Yes, you should have 10 numbers if you got them all. So in order to make my box and whisker plot, I need 5 data points. So over here, these vocabulary words, they're pretty important. These are the 5 data points that I'm going to need to make my box and whisker plot. The first data point is the minimum. Now, the minimum is pretty easy to find. It's just the smallest number in my list, and that would be 3 in this instance. The maximum is the largest number in my data set, and that would be 10. So minimum, smallest, maximum, largest. The median is the number that's in the middle. Once we have put them in order from smallest to biggest, it's the number that's in the middle. Or if you have 2 numbers in the middle, like in our case here, we have 10 numbers, so that is an even number. So that means I have 2 numbers in the middle. The 2 numbers in the middle are 7 and 7. So I would average those 2, and the average of 7 and 7 is just 7. If it had been 7 and 8, it would have come out to be like 7.5 or 7.5. So whatever your 2 middle numbers are, that is what you would average. If you have an odd number of numbers, it would just be whichever one number is in the middle. So 7 is my median. Now, the next 2 are the 2 that are usually new to students. So the first one says lower quartile. So in order to find the lower quartile, I am going to look at the first half or the lower half of my data. So that would be the 3, 4, 5, 6, and 7. And I want to find the median of the lower half. And so the number that's in the middle of the lower half is 5. So 5 is my lower quartile. And then I'm going to do the same for the upper half of my data. And the median of the upper half of my data would be 9. Right here. So quartile, quart, 4/4 in a dollar. Quart means 4, right? So if we divide our data into fourths, the 5 is 25% of my data. The median is 50% of my data. The 9 is 75% of my data. So 75% of my data would be 9 and below. And then up here at the top is obviously 100%. Now, sometimes you will see in some places, instead of calling it lower quartile and upper quartile, they will call it quartile 1 and quartile 3, with quartile 2 being the median. But for our purposes, we're going to call it the lower and upper today. All right, now that I have my 5 data points, I am going to put them on my box and whisker plot. So minimum is where 3 is, and the maximum is 10. So I'm going to put a dot above 10. And notice I'm not putting my dots exactly on the number line. I'm putting it above the number line so that I will have room to draw in my box and whisker plot. The median was 7. The lower quartile was 5, and the upper quartile was 9. Now, whenever I draw mine, I always like to start with the whiskers, and then I draw the box around the median. And then we just put our line right through the middle for the median. So that's all you have to do for a box and whisker plot. You have your minimum, maximum, median, lower quartile, and your upper quartile. There it is again. It is important that you know where these 5 data points are, because if they give you a box and whisker plot and they ask you questions, you have to be able to identify exactly where they are. The two that usually the minimum, the maximum, the median are pretty easy to spot, but sometimes students get confused with the lower and the upper. Just remember the lower quartile is the edge of the box and the upper quartile is the top edge of the box. So 2 vocabulary words that you may see sometimes when you're dealing with box and whisker plots. The first is range. So the range of your data is the maximum minus the minimum. So in our case, above the one we just did, the 10 was the maximum and the 3 was the minimum, 10 and 3. So the range of my data would be 7. It's spread out over 7 units. The interquartile range, which some people will refer to shorthand as the IQR, is the upper quartile minus the lower quartile, or the difference between the upper quartile and the lower quartile. So my upper quartile was at the edge of the box there was 9, and the lower quartile was 5. So 9 take away 5 is 4. Now, why do we care what the interquartile range is? So, for instance, if I have a huge set of data, okay, let's, and I'm trying to analyze it. Lots of times when I'm looking at my data, if I have, say, a long whisker on my data, then I might want to throw out that portion of my data, because maybe I have an outlier that is skewing my data. So sometimes it is important to just look at the middle of my data. So the interquartile range is actually how long the box is on my box and whisker plot. So in this instance, the IQR we said was 4, and we can see that my box is 4 units long. So that's why it is important sometimes, because sometimes you'll have a number that is a lot larger or a lot smaller than the rest of your data. So you might just want to look at the middle of your data. Not always, but sometimes. All right, so let's jump into some example test questions. And as always, if you want to pause the video, see if you can answer the question, and then turn it back on to see if you have it is correct, that's always a good thing to do. So example 1, this question is about test scores, and it says, what is the median of the data set? So let's say I had given maybe a quiz to my 150 students, and I wanted to analyze the data, but looking at a long list of 150 test scores is not very helpful. So I've organized it into this box and whisker plot. So I can see that the median is the line right here in the middle. So the answer to this question would be 60. So the median score on this test was a 60. Example 2. Oh, and they might ask you the median, they might ask you the minimum, they could ask you the maximum, they could ask you about any of those 5 points. They could ask you about the range or the interquartile range. Example 2, they're asking me about the interquartile range. So remember, the interquartile range is the lower and the upper. And the difference between the two. So my upper quartile is right here on 70 and my lower quartile is on 50. So this one is right here about 70 and this is about 50. So my interquartile range would be about a 20-point spread or 20 percentage points. So as a teacher, as I'm looking at this data, I would say, wow, these students didn't do very well on this test because that's somewhere in the DF range, low C. So I definitely need to go back and reteach this material because I can see that the middle 50% of my students, okay, that they got between the 50 and the 70%. So definitely not very good scores if you ask me. And I can also see that 75% of my students, okay, this is the upper quartile, so 75% of my students scored below, they scored a 70 and below. So definitely need to go back and reteach this, and that helps me to see it on this box and whisker plot. All right, example 3. Ooh, they've thrown 2 box and whisker plots on my number line. So maybe I'm still talking about test scores. Maybe I'm comparing 2 different class periods. We have class C and class D. And the question says, which class had more variability in their test scores? Remember, variability is how spread out is your data. So if I'm looking for the one that is more variable, more spread out, I am definitely going to say class C. Okay, because I can see that not only is the whole box and whisker plot longer, but also just the box itself is even longer than class D. So class D scores were more consistent. They were closer together. Everybody scored about the same, but class C, everybody was all over the place. Example 4, we're going to change it up a little bit. Now we're talking about monthly sales, and we can see that it's in money at the bottom. It says, which company had the highest median monthly sales? So now I am comparing 2 different companies. We have company A and we have company B. So they're asking me about the median. Remember, the median is this little line right here in the middle. So I can see that company A's median is about $400, and I can see company B's is about $550. So the highest median would go to company B. So they definitely had some better sales, it looks like. Now, last example question, example 5, which company's monthly sales were more consistent? So that means they had about the same, that their numbers are more tightly grouped, and that would mean that the box and whisker plot would be tighter or the box itself would be tighter. So in this particular instance, I'm going to have to say company A is definitely more consistent in this example. All right, I hope this video was helpful. Let's see if we check our learning target. Did we do what we set out to do? Students will be able to answer questions about a set of data using a box and whisker plot, and I would say we definitely successfully completed that. But if you still have questions, please drop me a comment, or if you liked this video, you can give it a thumbs up, or if you'd like to see more of them, go ahead and subscribe to my channel, and I'll see you in the next video. Thanks. Bye.